Welcome to my video on Unit 4, Part 2, Section 5, Solving Quadratic Equations by Factoring. Now, we started some basic solving by factoring in the last lesson, where we had equations set equal to 0, and we were able to, use basic trinomial factoring to find our results. So for the do now, we're actually going to take it up a notch and actually look at some more complicated forms of factoring that can also help us solve our quadratic or even higher powered equations. So let's take a look at the first one on the left hand side. Okay, so we're solving for x. We know that is the case because we see the equal to 0. Okay, so we know that we're going to be solving and getting values for x. And we know that we should be anticipating 2 values for x. So now our first line of defense here is to use factoring. So if we remember our factoring flow chart, right, the first thing we should always look for is a greatest common factor. So the greatest common factor between all of these terms is 5, which would leave us with x squared in my first term, minus x as my second term, and minus 30 in the last term. Okay, and again, we bring down the equal to 0. So now we take a look at the inside of our parentheses. Can this be factored further? And the answer is yes. This is a basic trinomial factoring. So we are looking for 2 numbers that multiply to negative 30 and add to a negative 1. Those 2 numbers being a minus 6 and a plus 5. Okay, so now we have all of our factors. Nothing can be factored any further. So different from yesterday is that we now have a greatest common factor here. We have a 5. So something that I typically do when I have a numerical GCF is I like to divide it out. Okay, because I know since this is multiplication between all these terms, that will cancel out the 5 here and here. And on the other side, 0 divided by any value stays 0. Okay, so I can eliminate that 5 just by dividing it out, and it really doesn't change the question all that much. Okay, we still have the equal to 0, which means I am still allowed to use my t-chart. So remember from yesterday, t-chart is when we separated our factors into 2 sections and set each one equal to 0. And then solve each corresponding mini equation to find the values of x that make this true. So we see for this question that my 2 solutions would be x equal to 6 and x is equal to negative 5. Okay, so we're going to follow similar steps for the second question, for the right-hand side question. But there's a few things we should notice. First off, we should notice that the highest power is not a quadratic. This is actually a cubic equation. Okay, so we do have that extra x value that we have to be mindful of. The second thing we should notice is that it is not in standard form. Okay, so now as a rule, we should always put any function we're trying to solve into standard form because that helps us with the solving process. So standard form means the highest powers go first and we continue with the powers decreasing. So instead of having the negative 3x at the end, we bring it to the front. And now we look at this new rearranged equation. Again, we're using factoring to solve this, so the first thing we should always look for is a GCF. But this time, my GCF is not just a number, but it's also a variable. So I know that I can take out a 3 from all of these because they're all divisible by 3, and I can take out an x. Now, the leading coefficient here, when it's in standard form, okay, is negative. So I'm going to encourage you as well to take out a negative value so that my leading term is positive and all the factoring techniques that we're used to can be done in a simpler form. So if I take out a negative 3x from every term, I get x squared, this changes signs, 2x left, And 189 divided by 3 is 63 plus, actually it's a minus 63 because the signs change. Okay, so now by taking out a GCF of x, what we actually did is we turned this cubic now into something that is quadratic and factorable. Okay, we see inside this parentheses that x squared minus 2x minus 63 is factorable using, right, two numbers that multiply to give me negative 63 and add to a minus 2. Those two numbers being minus 9 and positive 7. And again, I bring down my equal to 0. Now this time we have a different situation. In the last question, we divided out that coefficient. Okay, but we have to be careful this time because my coefficient now has an x value. So although we can divide out the negative 3, we cannot divide out by the x. Okay, you can't divide out by x because it's forgetting about the possibility of x being 0, because technically you can't divide out by 0. So instead of dividing out my leading factor, I'm going to separate them into 3 columns this time. One of the columns being negative 3x equal to 0. The other one being x minus 9 equal to 0, and then x plus 7 equal to 0. Now these ones we know pretty quickly. We get x is equal to negative 7, and we get x is equal to positive 9. But on the very first one, we know we do have to divide out by a negative 3. But just like over here, where dividing out a number didn't change 0, it's also not going to change 0 here. Okay, so we end up with 0 as our last answer. And notice we have a cubic equation, highest power 3. We now have 3 answers. Okay, so that's something to keep in mind moving forward. Okay, so these 2 questions were challenging in the factoring department, but they did have this equal to 0 in common. Not every question we're going to look at is going to be that nice. For example, we have these 2 right here, neither of which have equal to 0 already for us. So what do we have to do when it's not set equal to 0? We have to move terms over so that we force it equal to 0. Because the only way to solve this by factoring is going to be the 0 product property. So on this left-hand side, I'm going to move my terms towards the x squared since it's already positive. So I'm going to subtract 5x from both sides. We see that those cancel out. So when an entire side cancels out, we know we get 0. And we get x squared and the minus 4x minus 5 combined to give me minus 9x. Okay, so we got it equal to 0 in standard form. Now we can factor. This has a GCF of x, leaving me with x minus 9 as the other factor. Now we can separate it using our t-chart. My first factor of x equal to 0 can stay that way, and my second factor can be solved to get x is equal to positive 9. Okay, so we got x is 0 and x is equal to positive 9. Starting with getting it equal to 0, putting it in standard form, and factoring. So I'm going to challenge you to pause the video and attempt this second question. When you think you've got it complete, unpause and check your work. Okay, so again, we do not have equal to 0. So I need to move my terms over. And again, I like to move my terms so that my leading coefficient is positive. So that means the coefficient of x squared is positive. So I'm going to move x over here, and I'm going to move 1 over here. Notice I stack my like terms and do it all in the same step to make it a little bit easier. So I get x squared, and it's our lucky day, minus x and plus x cancel and go away completely. And I'm left with minus 25 when I added the constants. We see this is a difference of 2 perfect squares. So I can factor this into x plus 5, x minus 5, and set my 2 factors equal to 0. leaving me with the answers x equal to -5 and x equal to +5. And we're done. Okay, so for those of us who like steps and steps for solving, anytime we see we have a quadratic equation and we want to solve it by factoring, we should first put it into standard form and get it equal to 0. So that means move all the terms to the same side, okay, and make sure those exponents go from highest to lowest. Second, we make sure to factor the polynomial completely. That means GCFs, difference of two perfect squares, regular trinomial factoring, any method that we've learned so far can be applied to these types of questions. Once it is factored completely and it's all a multiplication question, we can use our T-chart to set each factor equal to 0 and solve each case. If we have an exponent of 2, you should be expecting 2 answers. If you have a little bit more challenging question, you have a highest exponent of 3, we should be expecting 3 answers. Okay, so now we're just going to switch it up just a little bit. Make sure we're still following these steps, but this time I'm going to give you this fraction equal to another fraction. Okay, so hopefully when we see this question, we recognize that this can actually be solved by cross multiplication. And the reason we can do that is because we have one fraction equal to another single fraction. So anytime that is the case, we can cross multiply by multiplying opposite numerator to opposite denominator, and the same on the other side. Once we've eliminated these double fractions, the rest is all about putting it into standard form, setting it equal to 0, and factoring. So I can distribute this x, and I can move this 24 over. Make sure when I rearrange these terms, they are in standard form. And now we look what kind of factoring, right? So it's a trinomial. Coefficient of x squared is 1. So I'm looking for two numbers that multiply to -24 and add to a +2. Those two numbers that I'm thinking of are going to be +6 and -4. Okay, set each factor equal to 0. And we get the answers. X is equal to -6. X is equal to +4. Okay, x is equal to -6 and x is equal to +4. So there is one last example that I'd like for you guys to try. Oops, sorry. And that's this one, solve for y. Okay, so what is different about this question? Well, we have an exponent outside of a binomial. So we have to remember what that means. So I'm going to ask you to pause the video, give this one a try, and when you are done, unpause and check your work. So remember, I'll use orange, that whenever we have a binomial set to the second power, it's like I have that binomial times itself, right? I cannot distribute the power. I have to expand this out. So I'm going to end up foiling to get y squared minus 3y minus 3y plus 9. Now I'm just going to combine my like terms while I'm at it. So I get minus 6y plus 9 is equal to 4y minus 12. Okay, so I do have to handle that exponent. But now I have no more exponents to worry about. I want to make sure I put this in standard form and set equal to 0. So that means I'm going to have to move everything towards the positive leading coefficient. So I'm going to subtract y, and I'm going to add 12, leaving me with a 0 on that side, and a y squared minus 10y plus 21. Okay, so now we have a trinomial. Okay, coefficient of y squared is equal to 1, so we're looking for two numbers that multiply to 21 and add to a -10. Those two numbers are -7 and -3. And so from there, we can set each factor equal to 0 and solve for the corresponding answers. So we get y is equal to a +7 and y is equal to a +3. Okay, so that pretty much sums up solving by factoring. Okay, we will look at some more challenging word problems and more challenging factoring types in the next lesson. But this is the basis, right? Solve for equal to 0. Make sure it's in standard form. Factor, T-chart, solve.